Redox reaction. An oxidation reduction reaction is a type of chemical reaction that involves the transfer of electron between two species. An oxidation reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. Here is the equation of it. Oxidation number and its rules of assigning the numbers. Oxidation reduction reaction are reactions in which electrons are lost by an atom or ion. One reaction reactant and gained by an atom or ion in another reactants, although electrons are gained and lost in these reactions. The balanced equation for redox reaction does not show the electrons that are being transferred. Oxidation number are hypothetical numbers assigned by the individual's atoms or ion atoms present in the substance using a set of rules. Oxidation number states can be positive or negative, or they may be a zero. It is very important to remember that oxidation numbers are always reported for one individual atom ion and not for groups or atoms or ions. Now the rule for assigning numbers are as the following rules for assigning it. Next one is a redox balancing chemical equation. Balancing simple redox structure can be a straightforward method of going back and forth between product and reactant. For example, in the redox reaction of Na and Cl2, you have an equation NaCl2 and NaCl2. You both have a fixed and balanced and non-balanced equation there. And third one is a balanced equation 2NaCl, 2 into 2NaCl. Here is an example and here is a solution of it. And we have the types of redox reaction: decomposition, combination, disproportionation, and displacement reactions. Here is the explanation of all that. Now we have the application of redox reaction in electrochemistry. The battery which we use for DC current was used like we have a vehicle and all the process and work that vehicle performed just because of the DC current that we used, and the storage cell are used in vehicles. Redox reaction in combustion. Combustion is a type of oxidation reduction reaction, and hence it is a redox reaction. And explosion is a fast form of combustion, as we know, just removal of one pin and the blast happens, and it's just a very rapid and very fast process. Now we have application in photosynthesis. Green plants that converts water and carbon dioxide into carbohydrates, and this process is definite. Uh, Definite as photosynthesis. The reaction uh, is given as. Next, we have a redox titration. Redox titration is basically reaction that between the analyte and the titrant is an oxidation. Next, we have application method, that is accurately telling that the samples and the ions and all that. Next, we have electrolysis. In order to predict the product of electrolysis, we first need to understand what is electrolyte. We have to know what is electrolysis, and electrolysis is a method of separating bonded elements and compounds by passing an electric current through them. It uses a direct electric current, like we can also call as DC current, and this is an electrolyte, a DC supply, two electrodes, and electrolytic cells. It is a cell that converts electrical energy into chemical potential energy, and this is known as electrolysis. Faraday's first law, it's a brief explanation, but it is clear that the flow of current through the external battery circuit are fully dependent upon how many electrons get transferred from negative electrode and cathode to positive metallic ion are cations. If the cations have valency of 2 like Cu plus means 2 positive, and it's have also a negative electric charge which is 1.62 into 10 raised power 9, and coulombs according to coulombs it is minus 1 and minus 2 charge transfer from cathode to anode. Next, we have the first law of Faraday electrolyte states that the chemical opposition but to the flow of current through an electrolyte is directly proportional to the quantity of electricity. Next, Faraday's second law of electrolysis, which is also stated that the chemical deposition due to electrolysis is proportional to the quantity of electricity that passes through the electrolyte. The mass of the chemical deposition due to electrolysis is not only proportional to the quantity of electrical process through it. Again, we have our explanation, and now we have the Faraday's second law of electrolysis that states that the same quantity of electricity passes through several electrolytes, but the mass of the substances represented are proportional to their respective chemical equivalents and equivalent weight. Next, we have electroplating, which is a process plating one metal onto another by hydrolysis, most commonly for decorative purposes to prevent corrosion of the metal. We have a following types of electroplating, like we have mass plating, we have a rack plating, we have a continuous plating, we have a line plating. Now we have electromagnetic radiations. It is the energy that is propagated through free space or through a material medium in the form of electromagnetic waves such as radio waves, visible light, and the gamma rays. The Scottish physicist Maxwell Clerk was the first man who predicted the existence of electromagnetic waves. In 1864, he set forth his electromagnetic theory, proposing that light, including various other forms of radiance. And here is the second scientist in 1877 who provided the experimental confirmation by producing the first non-electromagnetic waves. And here is a magnetic field. We have electric field in it. We have a magnetic field in it, and we have a wavelength which is inversely and directly proportional to each other. Basically, it is established that the time varying electric field can induce magnetic field, and that time varying electric fields can, in like manner, induce electric fields because such electric and magnetic fields generate each other. They occur jointly and together they propagate as electromagnetic waves. Next, we will learn about main difference continuous spectrum versus line spectrum, in which the spectrum is set for the wavelength and its characteristics of radiation which is emitted are absorbed by a particular object, substances, atoms, or molecules. Now we have a radiation chemistry. Radiation chemistry is a branch of chemistry and a subdivision of nuclear chemistry. Radiation chemistry studies the chemical changes resulting from the absorption of high energy ionizing radiations, for example, alpha particles, electrons, gamma rays, protons, and heavier charged particles. We have a types of ionizing alpha, beta, gamma, and X-rays. Alpha radiations, we have the explanation of it, and next we have a gamma, we have beta, and we have X-rays. This one is the gamma radiations, and this one is X-rays. Now we have a nuclear stability. Nuclear stability means that the nucleus of an element is stable and thus it does not decay spontaneously, emitting any kind of radioactivity among the nuclei expected to exist, and presently only 195 are stable against spontaneous decay because of energy conservation. Ionization is the process by which ions are formed by gain an atom or molecule. If an atom or molecule gains an electron, it becomes negatively charged, and if it loses an electron, it becomes positively charged. Energy may be lost or gained in the formation of an ion. Next, we talk about half-life. Half-life is the time required for a quantity. Time required for a quantity to reduce to half of its initial value. that the physicists to describe how quickly a stable atom undergo or how long stable atoms survive radioactive decay. The term is also used more generally to characterize any type of exponential or non-exponential decay. For example, the medical science refer to the biological half-life of drugs and other chemicals in the human body. The converse of half-life is doubling time. Next, we talk about radioactive chemistry, which is the emission of particles from nuclei because of the nucleus and its instability. It is the radioactivity. Next, we have nuclear chemistry. Nuclear chemistry is a subfield of chemistry dealing with the radioactivity, nuclear process, and transformation in the nuclei of atoms, such as nuclear transmissions and nuclear properties. It includes the study of the production and use of radioactive sources for a range of processes, spontaneous fission, it's a form of radioactive decay that is found only in very heavy chemical elements, in which we have a small nuclei or nuclear particles that are possible and the great atomic mass numbers. Photoelectric effects, it is a emission of electrons or other free carriers when the electromagnetic radiations like light hits a material from this perspective and can alteration in the intensity of light in the system. The magnetic energy of the electron emitted from the metal. Compound effect is a name given by physicists to the collision between a photon and an electron, and the production is the creation of subatomic particles and its antiparticle from a neutral person. Example include creating an electron and a positron, a mode, and an antinon. Annihilation process in particles, physicians say the process occurs when the subatomic particles collide with the respective antiparticles to produce other particles such as two photons, total energy and momentum of the initial pair are conserved in the process and distributed among a set of other particles in the final state. Antiparticles are exactly opposite and two quantum numbers for a particle, so the sums of the quantum numbers are highly, they are also highly particles and they are the particles that are created. Now we have radiation energy. Physics radiation is the emission or transmission of energy in the form of waves or particles through a material medium. This includes electromagnetic radiation such as radio waves, microwaves, X-rays, gamma rays, and infrared radiations. Assalamualaikum. Today my topic is electromagnetic radiations. Basically, the radiations are the energy that is propagated through free space or through a material medium in the form of electromagnetic waves such as radio waves, visible light, and gamma rays. The term also refers to the emission and transmission of such radiant energy. The Scottish physicist James Clerk and Maxwell was the first uh, to predict to existence of electromagnetic waves. They said that there are electromagnetic waves. In 1864, he set forth his electromagnetic theory proposing that light, including various other forms of radiant energy, is an electromagnetic disturbance in the form of waves. In 1887, Heinrich Hertz, a German physicist, provided experimental confirmation by producing the first man-made electromagnetic waves and investigating their properties. Subsequent studies resulted in a broader understanding of the nature and origin of radiant energy. Here we have an electromagnetic field, we have an electric field, we have a magnetic field here and wavelength, and they are moving upward and backward direction. It has been established that time varying electric fields can induce magnetic fields and that time varying fields can in like manner induce electric fields because such electric and magnetic fields generate each other. They occur jointly and together they propagate electromagnetic waves. And electromagnetic waves is a transverse waves is that the electric field and the magnetic field at any point and time in the wave are perpendicular to each other as well as to the direction of propagation in free space, that is space that is absolutely devoid of matter and that experiences no instruction from the other field or forces. Electromagnetic waves always propagate with the same speed that of light. Here we also discuss about the light seconds. which is independent of the speed of the observer or of the source of the waves. Electromagnetic radiations has properties in common with other form of waves such as reflection, refraction, and diffraction and interference. Moreover, it may be characterized by the frequency, which varies over time and by its wavelength. Electromagnetic radiations, however, has practical like properties in addition to those associated with wave motion. It is quantized in that for a given frequency, its energy occurs as an integer times h, in which h is fundamental constant of nature known as Planck's constant. A quantum of electromagnetic energy is called a photon. Visible light and other forms of electromagnetic radiations may be thought of as a stream of photons with photon energy directly proportional to the frequency. Electromagnetic radiations spans an enormous range of frequencies or wavelength, as is shown by the electromagnetic spectrum. Customarily, it is distinguished by the frequency radio waves, microwaves, infrared rays, visible light, ultraviolet wavelengths, and are inversely proportional, and both the frequencies and wavelength scales are logarithmic. Electromagnetic radiations of different frequencies interact, and the vacuum is only the perfectly transparent medium, and all material media absorbs only some regions of the electromagnetic spectrum, for example, molecular oxygen, ozone, and molecular nitrogen in the Earth's atmosphere are most perfectly transparent to infrared rays. The frequency of X-ray is substantially higher. Here we talk about the frequency of X-rays. There's one. Say that the frequency is higher. Then they penetrate. The X-rays are able to penetrate many materials that do not transmit light. If these processes occur in living tissues, the photoelectrons destroy the cell of the tissues. Gamma rays, so generally of somewhat higher frequencies than X-rays, are basically the same nature when the energy of gamma rays is absorbed. Radio waves, for example, are produced by cosmic objects such as pulsars and by electronic circuits. Sources of ultraviolet radiations include the intensity and the accelerators and electronic devices. Main difference: continuous spectrum versus line spectrum. A spectrum is a set of wavelengths that is characteristic of electromagnetic radiation, which is emitted or absorbed by a particular object substance at an orbital. Color of the rainbow, microwaves, ultraviolet radiation, and X-ray are some examples. A spectrum is the characteristic of the element present in the material considered. Continuous spectrum and line spectrum are two types of spectra. Their main difference is that continuous spectrum contains no gap, whereas a line spectrum contains many gaps between it. However, important to know that more about absorption spectrum and emission spectrum, which are the two main spectra before learning the difference between continuous spectrum and line spectrum, since both absorption are and emission spectrum. Radiation chemistry basically uh, is a branch of chemistry and a subdivision of nuclear chemistry. Radiation chemistry studies the chemical changes resulting from the absorption of higher energy ionizing radiation. For example, alpha particles, electrons, gamma rays, protons, and heavier charged particles. Here we have a types of ionizing alpha, beta, and gamma radiation, that X-rays. Here we discuss all the radiations, gamma, beta, X-ray. Now we have a nuclear stability. Nuclear stability, if we talk about it, it means that the nucleus of an element is stable and thus it does not decay spontaneously, emitting any kind of radioactivity. Among the 900 nuclei, ionization is the process by which ions are formed by gain or loss of an electron from an atom or a molecule. If an atom or molecule gains an electron, it becomes negatively charged, and if it loses an electron, it becomes positive. When it loses an electron, it becomes positive and charged at a time. Energy may be lost or gained in the formation of an atom. Next, we talk about half-life. Half-life of ionization. Half-life required is the time for a quantity to reduce to half of its initial value. The term is commonly used in nuclear physics to describe how quickly unstable atoms are unable to radioactivity decay. Next, we have a radioactive chemistry. It is basically emission of particles from nuclei because of the nuclear instability is known as radioactivity. The substance that releases such energy are X-rays known as radioactive substances. Nuclear chemistry is the branch of chemistry. Basically, it's a subfield of chemistry dealing with radioactivity in nuclear processes and transformation in the nuclei of atoms, such as nuclear transmissions and nuclear properties. It includes the study of the production and use of radioactive sources for a range of processes. Next, we have a spontaneous fission. It's basically a form of radioactive decay that is found only in very heavy chemical elements, that the nuclear binding energy of the elements reaches its minimum at an atomic mass number of about 56. Spontaneous breakdown into smaller nuclei. Photoelectric effect is basically the emission of electrons or other free carriers when electromagnetic radiations like light hits a material. From this perspective, an alteration in the intensity of light induces changes in the kinetic energy of the electrons emitted from the metal. Quantum effect, it's basically an effect by photosynthetsis to the collision between a photon and an electron. The photon bounces off a target electron and loses energy. The effect was discovered in 1922 by the American physicist author H. Captain. The pair production is the creation of a subatomic particles and its antiparticle form a neutral Gaussian example include creating an electron and a position of an antinon on a proton. Next, we have an annihilation process. It's basically a particle of it's basically a particle of physics, which annihilation, the process that occur when a substance particle collides with its respective particles and to produce particles like colliding particles that produce two photons for the production. And next we have a radiation energy. Physics radiation is the emission transmission of energy in the form of waves or particles through space or through a material medium. This includes electromagnetic radiations such as radio waves, micro X-ray, gamma, and infrared radiations.